Okay, question 7. We've got a cylinder of water. There's a hole in my bucket, dear Liza, and here's the hole, and water is leaking out such that the height goes down, presumably to the limit of the height of the leak. So initially the tank was full of water, so the height above the base was 1.5. We've got an equation here for the rate of change of that height of water in terms of an exponential curve controlled by E. The first thing we've got to do, we've got to get an equation for h from the differential, which means we need to integrate. So there's the initial equation. So we know that h must be equal to the integral of dh dt, which is equal to the integral of this lot. Now, immediately I'm going to put my negative 0.12 outside the integral sign. So there's my simplified equation. So the integration of e to the minus 0.2t using the reverse chain rule will be e to the minus 0.2t. And we've got to multiply this by 1 over minus 0.2. You can check that by differentiating. And we must put our constant out the front again, which is 0.12, but it's negative, and plus c. And this is equal to, the negatives obviously go, we're left with 0.6 e to the minus 0.2t plus c. So to solve for c, we can substitute t is equal to 0, h is equal to 1.5. Remember, this is the equation for h. So I get 1.5 is equal to, anything raised to the power 0 will be 1. So this is 0.6 plus c. And therefore c is equal to 0.9. So going back to their equation, so therefore a is equal to 0.6 and b is equal to 0.9. And that's the answer to part A. So in part B, we've got to find the time taken for the water to decrease to 1.2 meters. Give your answer in hours and minutes to the nearest minute. So we need to find the time when h is equal to 1.2. Remember, this is now equal to our full-blown equation here, which is 0.6 e to the minus 0.2t plus 0.9. So therefore I can say 0.3 divided by 0.6 must be equal to e to the minus 0.2t. Simplifying further, this is a half is equal to e to the minus 0.2t. So taking logs, I get that ln a half is equal to negative 0.2t. And if you solve for t, you get that t is equal to 3.4657. And if you work that out to the nearest minute, remember this is a decimal, not anything to do with seconds, t is equal to 3 hours and 28 minutes. And that's the answer to part B. So in part C, we're to find that in the long term, the water level clearly will fall to the level of the hole, which is at L, and we need to find the height of that hole. So t is now very big, which in our h equation here means that this whole term will go down to 0. So in the end, h will equal b. And as we know that b is equal to 0.9, this will be the answer. So I can say that 0.6 e to the minus 0.2t will go to 0. And therefore, h, the remaining bit of the equation, this having gone, h is equal to 0.9. And that's the answer for part C and the end of the question.